All right, so here is our challenge problem for graphing a function, and this is a particular type of function called a piecewise function that's made of a few different pieces. So in other words, based on what x is, there are different rules that we need to follow to determine what y is. So it's a function that has different equations for different values of x. And I encourage you to give this a try on your own, see if you can do it, pause the video, and then check back in and follow along and see how you did. So first we will label our table, x and y, and I am going to think about what my x values are if x is less than 0 versus if x is between 0 and 2 versus if x is larger than 2. So that's a little bit of a clue that maybe I need to start a little bit less than 0 for my scale, 0, 1, 2, and go a little bit larger than 2. Okay, so let's see here. We really just need to plug in some points. So for x is less than or equal to 0, let's plug in the x squared rule for y. And so this is going to be a 4. Negative 1 squared is 1, and a 0 squared is 0. Okay, and what I want to try to show here is how I'm following the different equations. Now we need to find y equals 2x, and that's for x's between 0 and 2. So we plug in 0, y is 0, and here it's 2, and here it's 4. So for that rule, we got these points. And then y equals 2 to the x power, okay? So when x is 2, we have a 4. 2 to the 3 is 8, and 2 to the 4 is 16. So just to be clear, for this rule, we got those points. And what's nice is that the overlapping points agree. Okay, if we got different values, then we might need to plot both of them, and we would have to think carefully about what that meant. Sometimes for a particular x value, y could have 2 different values. Then it wouldn't officially be a function, but we could still plot it on a graph. Sometimes you need to look carefully at the less than or greater than signs and see if it's less than or equal to or less than. And in those cases, you might draw some open circles for one of the points and a closed circle, a closed dot for some of the other points. But we didn't have that issue here. We can go ahead and just plot them up. X, we're going to have to go from negative 2 up to 4. 1, 2, 3. And it looks like y, we need to go up to about 16. 2, 4, 6, 8. We might not make it, but we'll try. 12, 14, and I'll try to go up to 16 there. Okay, cool. So let's go ahead and just plot our points. When x is negative 2, y is 4. That's right there. X is negative 1, y is 1. And x is 0, y is 0. Okay, so I'm going to, before I get maybe a little bit confused by the other equations, I'm going to plot these. It looks like it's a bit of a curve, and it should be because it's a parabola right there. Now let's do the next one. X is 0, y is 0. X is 1, y is 2. X is 2, y is 4. That looks like a nice straight line right there. And then lastly, we have that exponential piece. Over 2 up 4, over 3 up 8, and over 4 way up to 16. That's a bit of a curve as well. It's not going to be as obvious when I draw it, though. Okay, and then just to be really clear, this is the purple part of our function. This is the red linear part, and this is the orange quadratic part. So we have one single function. It's composed of multiple pieces called a piecewise function. And that's a good place to stop right there.